Well, good evening or good morning or good afternoon, whatever time of the day that you're watching this video. Today, in this video, I'm going to go over logarithmic properties. Now, what I want you to keep in mind when we go over these properties of logarithms is that a logarithm is simply the inverse of an exponent. So they are related to one another, and if you keep that in the back of your mind, it's easier to understand and remember these logarithmic properties. It's kind of hard just to always remember these and just memorize, and it's a better idea to understand where they come from so that you don't have to memorize them as much. So let's take a look at some common logarithm properties. First, our exponent property is b to the 0 equals 1. So the logarithm property that goes along with that would be that the log base b of 1, so any logarithm of 1 is equal to 0. If we have a base and the power of 1, we know that that's just equal to b. So we're going to do log base b of b is equal to 1. So if these base and the logarithm match up, then the logarithm is going to be equal to 1. So whenever we have two and have the same base and we multiply them, we're going to add the exponents together, right? So what does that look like in logarithms? Well, in logarithms, it's the log base b of m plus the log base b of n. We can combine these two logarithms just like we combined these two exponents. We're going to combine them, log base b, by multiplying m and n. So just like this, we're kind of going in reverse. So what happens when we divided 2? We subtracted the exponents. So it works the same way here. Log base b of m minus log base b of n is equal to log base b of m over n. Again, we're just subtracting, so we're going to divide. Here, we're subtracting the logarithms. We're going to combine them by dividing the inside. Well, when we raise a power to a power, we multiply the powers. So the way that looks in logarithmic form is the log base b of x to the m, I know I'm using different terms here, is going to be equal to m times log base b of x. And we can explore this a little bit more using the logarithmic conversion. But basically what I'm trying to say is that if you have an exponent here, you can actually bring this exponent to the front of the logarithm and multiply the logarithm. So it's like you're multiplying powers here. And the last one, this is called the equality. Okay, this is called equality. So if you have the same base, you can set the powers equal to one another. And that works the same for logarithms. So if you have two logarithms that are equal to one another, that have the same base, then that tells us that the inside, or the logarithms, are also equal to one another. We're going to use this one in the next video. We're going to just look at how we use these right here, that one too, how we use these right here in some examples. This looks kind of like a face, huh? Alright, so let's take a look at a few examples. So in my first example, simplify, sometimes we see it as condense, the expression 2ln x plus 3ln y. Remember that ln is the same as log base e, okay? So this is a really important thing to remember. But in this case, we're just looking at properties. So if you want, you can pause, go back to the list of properties, and see how these are going to take effect. So first of all, we've got this here, 2ln x. Now, the last property I stated that you can have a power and bring it down. Well, you can also have a power, you can have something multiplied and bring it up to the power. So same thing here, we've got a 3 multiplied by the logarithm, we're going to bring it up to the power. So we're going to have ln of x squared plus ln of y cubed. Then there was a property that stated if we have two logarithms and we add them together, then we can multiply the insides. So I'm going to have ln of x squared times y cubed. And this is going to be my answer. Okay, I've condensed it, I've put it into one logarithm. Okay, let's take a look at the next example. So now we have a little bit longer here, 2 log x plus 1 minus log x. So the first thing we're going to do again, if ever we see something multiplied by a log, we're going to take that and bring that up to the power. So we're going to have log of x plus 1 squared minus log of x. Now if you remember this from Algebra 2, or you're looking at this from Algebra 2, a log, when it just says log, that means log base 10. It's called a common logarithm. We actually don't use common logarithms all that much anymore. We used to use them a lot when our calculators couldn't do log base of things, but now that we can do log bases and we don't need log tables, and we have good calculators, we don't really use common logarithms as much anymore. But just so you know, it means log base 10. So back to the problem here at hand. We've got log of x plus 1 squared minus log of x. Now we have a minus here, so we're gonna put them together, and we're going to divide the two things that are inside the logarithms. Okay, so this is going to be our answer, and that's it. Okay, let's take a look at a few more examples. Again, if you want to try pausing the video so that you can try the example before I go over it. It's sometimes a good idea to get some practice in here and then watch the video. So again, we're going to take this 3 and we're going to bring it up here and multiply it by this power. So we're going to have ln of e to the 2x times 3, okay, because it's raised to a power, plus ln of 2 times ln of 1. Well, you know what? Before we do anything here, we know by the first property that the ln of 1, the log of 1 is always going to be, that's right, 0. So here we have 2 times 0. So really, this whole thing right here, this thing is just 0. So why don't we just put 0 here from the beginning? Alright, so now we have ln of e to the 6x. Well, notice here, remember that I said that log base e is ln. So this really here is log base e of e to the 6x. And we actually went over a property in class that said that this here, if these match, then we simply have the power, 6x. This is actually going to be our answer. Now, if we want to look at using the properties that we just did, we can go back here and notice that we can take this and bring it actually to the front here. So we're actually going to have 6x times log base e of e, and one of the properties stated that if these bases are the same, then we're going to just have that to be equal to 1. Okay, so that's why we get 6x here. I think a very important thing to know, though, is that whenever you see ln of e, you should notice that that's 1. Or ln of e raised to any power is going to be whatever that any power is. Okay, so I think that's an important point to make from this example. All right, let's take a look at another example. Oh, now this one's a little bit different. This time we want to expand. So instead of condensing it into one logarithm, we're going to expand it into several logarithms. So an easy thing to do here is just see what's on the bottom. If it's on the bottom in the denominator, we're going to have a subtraction. If it's in the numerator, it's going to be an addition. So the first thing I'm going to do is I'm going to separate the bottom from the top by using a subtraction. Okay, and then I'm going to separate these by using a addition, and we get these from the quotient and product rule that we just saw. And then we're going to bring the power in the front here, 2 log x plus log y minus 3 log z, and there we go. So we expanded it by using the properties of logarithms. All right, just a few more. I think I only have one more example here for you. So let's take a look at the one more example. And we're going to expand this, so knowing what you just did in the last one, you might want to try this one on your own. Okay, so again, we're going to we're going to separate this by using ln of e squared x cubed minus ln of y to the negative 2. I'm going to separate this even more. So ln of e squared plus ln of x cubed minus ln of y to the negative 2 power. Now notice from the previous, was it 2 examples ago, I know now that ln of e squared is simply 2 because these two match up, right? And then we're going to put the 3 in front here, so we got 3 ln of x. And we're going to put the negative 2 in here. Negative 2 times a negative is a positive 2 ln y. And this is our solution. Okay, so that's using properties of logarithms. I'll make sure I don't have any more. That's our last one. So we will see you soon. Bye-bye.